So this is a review as to figuring out how to classify polynomials, whether they were even positive or negative or odd positive or negative. And so I thought that I would put some of these up here. This is an even positive. This is an even negative. So the even positive is going to be up, up. And the even negative will be down, down. Okay, so this is Rocky. Yeah. Adrian. Hulk. Urgh. So whenever we're talking about even powers, it's if you've got the, when you classify the polynomial, the even powers would be the quadratic or the quartic, or if you have the leading power to be x to the sixth, x to the eighth, it applies to all of those. Now, looking at it positive is you're looking at the leading coefficient. Is the leading coefficient positive or negative, which is referred to as A? Now, when we write our end behaviors, for the left side on the even positive, it's as x approaches negative infinity, that's the left-hand side. So we're looking on this left-hand side. What is the graph of f of x doing? Or in other words, what are the y values? What's happening to that? It's approaching infinity. It is up on the left-hand side. Well, what about the right-hand side? The right-hand side is positive infinity. So as x approaches positive infinity, so this is the right side that we're talking about, f of x is approaching positive infinity, up. Now let's look at the even negative. So on the left-hand side, this is the left-hand side, x approaching negative infinity, it's down. So f of x is approaching negative infinity. And then on the right-hand side, as x is approaching positive infinity, it's the right-hand side, it's still negative infinity. So with your end behaviors for the evens, they are the same. On this one, if it's positive, f of x is approaching infinity on both the left and the right. And then if it's negative, they're both approaching negative infinity, both left and right. Okay, so this is the best thing that I can get to the closest of the odd, positive, and negative. So here is an example of an odd negative because it's going up, down. Now, if you picture John Travolta turning around, all the guys are like, ugh, I don't want to look at his butt. But I want you guys to look at it being down, up. All right? Staying alive, staying alive. So the odd positive is down, up. And the odd negative is up, down. So let's look at the end behaviors. So we're going to be looking at the left end behavior. What's happening on the left-hand side? Well, it says down right here. So f of x is, since it's going downward, it's approaching negative infinity. Well, what about the right side? So we're looking at the right side here. X approaches infinity. That's the right side of the x-axis. F of x is moving up. So f of x approaches positive infinity. Now, if we were to look at the odd negative, it's up, down. So x approaches negative infinity. That's the left-hand side of the x-axis, and the graph is moving up. So f of x is approaching positive infinity. And then on the right-hand side, as x approaches on the right-hand side, positive infinity, which is on the right side of the x-axis, then f of x, or the graph, is moving downwards, so it's negative infinity. So this is an overview of the even, positive, negative, and odd, positive, negative. So now if we were to name the domain here, since this graph has an arrow here, it is moving towards the left here, so, and it just keeps going, so it's negative infinity. And then on the right hand side here, this graph is still moving outwards. So remember, domain is looking how wide is the graph. Well, it's infinitely wide, from negative infinity to infinity. Now the range is how tall. So we go along the y-axis here, and so this is infinitely going downwards, and this is infinitely going upwards, and the range is named off the y-axis from the bottom to the top, so it's infinitely tall. So the range is negative infinity to infinity. Okay, so the next thing is that we have to name our relative max. Well, our relative max is actually going to be right here. And this is going to be our relative minimum. Okay, so I want to clean this up because I want to talk about increasing and decreasing. So let's split up each of these intervals. If we look at this graph here, you see how it's moving up, and now it's changing directions, and it's changing directions again. And so I want to split it up where it starts changing directions. So I split this into 3 different parts. Here's the first part, here's the second part, and here's the third part. And the reason why is because something is happening here and here. So if I was to name this first part, I'm naming it in the interval along the x-axis. And so this first part would be from negative infinity to -4. Okay, now one thing to be very careful with is that we're only naming the axis, the x value. We don't use 5 at all, okay, because that is the y value. All right, and so the next part here is going from -4 to -2. And again, like I said, we have to look at the x value only. And then the third section here is going to be from -2 here all the way to infinity. So now we want to name the intervals. Which intervals does it show that it's increasing? So what we're looking at is we're looking at this graph is moving upwards. This part isn't moving upwards, it's going another direction, but this is moving upwards as well. And so if we were to name the interval where f of x is increasing, it would be negative infinity to -4, which we're naming this interval, and then -2 to infinity, and then we just include the union here. All right, so where is f of x decreasing? So if you look at this graph, it's moving downward here. And remember, we name only the x values of that interval. So it's decreasing from -4 to -2. Now, if we were to look at the end behaviors, this ends up being down, up. And so if we were to name the left side as x approaches negative infinity, so we're looking at the left hand side here, this is moving downwards, so that means that f of x is approaching negative infinity. On the right hand side, as x approaches infinity, what is f of x doing? What is f of x approaching? Well, it's moving upwards infinitely, so it's approaching positive infinity. And if we were to classify, just so you know, since it's down up, f of x is a cubic function and it's positive. So just remember, if it's a is positive or negative, we look at the leading coefficient. And so um, since 3 is an odd number, it would be odd positive. But when we classify it, it would be a cubic function.